Hi, it's Miss Jessica here. We are going to be doing a brake inspection on a 1995 Jeep Cherokee. So I'm going to go ahead and go grab it. So now that we got the Jeep in the air, I'm going to kind of show you guys where the racking points are. So as you can see right here, we have it nice and solid on the frame. That's going to be both the front and the rear on all sides. And then remember when you guys are racking it up that you let the vehicle come up a couple inches off of the ground and give it a nice good shake, because it's better for the car to fall low to the ground than up in the air when you're working on it. So as you can see, we have the car all racked up and ready to go, but before we even brought it in, the very first step that you want to do is obviously test drive the vehicle. You want to go ahead and take a look at your work order, see what the customer concern was, you know, your first one of your 3 C's, and you want to try to test drive the vehicle and duplicate what the customer complaint is. So that way you can verify what it is that you're noticing, whether it's a sound, vibration, what have you, and it matches with the customer's description, which allows you to kind of know exactly what you need to look for, and it helps you to make sure that when you're doing the repairs, you're actually going it towards what the customer's complaint was when it first came in. So we have the car racked up and ready to go. So now what we do for the brake inspection is we're doing 4 on the floor. So that means not just the left side of the vehicle's tires are coming off, all 4 of the tires are coming off, and you're going to be doing a solid, thorough inspection on each and every single wheel. So you grab your impact, you grab the correct socket. In this case, ours is a 13/16 socket, and you're going to go ahead and take off the tires, or the lug nuts to take off the tires. Now what I like to do is I like to remove the sockets, or the lug nuts, in a star pattern. I have 5 lug nuts, so I take them off in a star pattern, just like I would put them on in a star pattern, and I would torque them as a star pattern. One thing I do want to mention is, as you can see, we have our tires right here in front of the rack. So it's out of the way of everybody else, so it's not blocking and impeding traffic, which of course is going to be a safety concern. And we also have it going underneath the arms that we have here. And this is a great thing to do because it's also a safety thing. So in case anything happens and it drops, it can drop onto the tires. And as well as, again, it's out of the way, so we can get up here into the brakes and we're not stepping over the tires. It's out of the way of everybody else. As well as it's better to have them laying down flat like this, because we can still go ahead and drop the vehicle down without having these tires standing up and getting in the way. So now that we have all the tires off, one of the things we're going to start doing is measuring things. We're going to measure the pads, we're going to measure the rotor thickness. So one tool that we use a lot for measuring pad thickness are going to be these ones right here. Back in the day, you may have seen something that looks like this, but this is a lot easier to use, and as you can see, it's color coded, so it's very quick and easy to identify that, oh, if it's this low of pad thickness, it's in the red, obviously it needs to be replaced. Green, good. Yellow, it's suggested and recommended. So what we do with this is we go ahead and take a look at our pads. So it looks like we have quite a bit of thickness left on those, so I already know we're probably going to be in the green. So I'm going to go ahead and take the green, and we're going to go ahead and stick it in between the rotor, just like this on the side. We're going to stick it in between the rotor, and we're going to see how much space we have. So right here we got plenty of space. We're going to go ahead to the next side, that's up. We're going to go in, ooh, that's a pretty good size fit right there, so we still have enough space there. And then we're going to go with the one that's right above that, and we're going to try to put it in. It's not able to go in. So off the bat, I already know it's going to be between the 10 and the 12 millimeters. So we're just going to go ahead and say roughly that's about 11 millimeters. And it's in the green, so we know it's good. Same thing you're going to do for the other side. You're going to go ahead and put it in. All right, that fits nice and good. Let's go this one. Oops, that one doesn't fit. So again, we know that that's between about 12 and 10 millimeters. And again, that means it's good. And it's also good to notice too is that both sides of the pads, the inside and the outside, are roughly the same thickness, so that's a good indicator for us going forward with the brake inspection. And then the next measurement that we're going to be taking is going to be measuring our brake rotors. So you guys must have seen this before. This is our micrometer that we're going to be using. What we can do is we're going to take a look, and we're going to see if we can find any open spaces between the backing plate and the caliper to see if we can put this in. We're lucky that our particular vehicle has a little gap right here that we can use, so we would just go ahead and slide that in and do our measurements, which you'll see in a second. There's also another tool that you guys can use that you guys should be familiar with as well. We got our handy dandy dial indicator. This particular indicator is really cool because it has this little lip here that we're actually able to go ahead and put between the rotor and the backing plate so we can go ahead and do the measurements. And what's even better about this is that we're able to kind of angle this to a good viewing point so we can take a look at it, and it's a lot easier to read than the micrometer. So before we get started with the dial indicator, one of the things we want to do is we want to set it to 0. So this particular one comes with a 1-inch standard because our micrometer is reading from 0.00, oh, this is a 10,000ths. This reads at a 10,000th of an inch to 1 inch. So we got our 1-inch standard right here. So what we do is we put it between the plate and the tip of the dial indicator as so. And then as you can see here, it's not quite at 0. So what we're going to do is we're going to rotate the face until we get to the 0 mark. So the needle looks like it's at the 0 right there. So now we know that we are zeroed out, and whatever measurement we're going to be getting right now is going to be accurate. So again, we're just going to go ahead and take our dial indicator, put it between our backing plate and our rotor, and we're going to go ahead and take a look at it and read it. Alright, so it looks like we're going to be at 0.948 of an inch. Alright, and now we're going to go ahead and showcase how we're going to use the micrometer and kind of let you guys see both ways of it being used. So we're lucky that in this case that we have this little gap here between the backing plate and our caliper, and we're going to go ahead and measure right here. So we're going to go ahead and take our micrometer here. We're going to go ahead and put it on our gap. You can see our scale is right here. And I'm just going to go ahead and tighten it up. And so we're going to go ahead and read the micrometer. So right here we have our 9. I can see that we have a dash right here. So we have 9 and 25. And then if we take a look over on our barrel, our line is in between the 23 and 24. So it's going to be 0.023 because we always go with the smaller number when it's in between the lines like that. So we're going to get 0.948 inches. So another thing that we're doing during brake inspections is we're checking everything in this area. We're going to be checking our brake lines to make sure that we don't see any leakages. We're going to take a look at the back, and we're going to follow them along as well. Another thing that we can do when we're here is we can go ahead and take a look at the suspension and steering parts. So we can go ahead and take a look and see if we see any axle leaking. As we can see right here, our shock is actually seeping a little bit. So because we'll find out later when we get into the suspension portion of it, your suspension does affect your brakes. So this is definitely something you can write down in your brake inspection report, and you can suggest it. But yeah, so again, we're just going to go ahead and take a look at everything, make any notes or comments that we have, and then we're going to go ahead and start taking a look at the rear brake drums. Alright, so we just went ahead and finished our front brake inspection on this vehicle, and now it's going to be the rear's turn. So we have our drums right here, so the first thing you want to do is obviously remove the drum. So we're going to go ahead. So apparently this one's pretty stuck, which is actually a very common thing that happens with rear brake drums. It gets seated right along here. So one thing that you can do is go ahead and get a dead blow hammer, and you're going to go ahead and just whack it. Now you're not going to go crazy and whack it like your Thor or anything like that, but what you're going to do is you're going to go ahead and see this lip, this edge. Just go ahead and take your hammer and just give it a, and as you can see, and you can hear it obviously, it went ahead and moved, and so now we should probably be able to go ahead and remove the drum. So just wiggle, 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 and we have our drum. So we're going to go ahead and measure our drum real quick. So one of the things that you want to do is you want to go ahead and get a tape measure, and you're going to measure the inside diameter of the brake drum. So this is going to help you when you do your brake mic. So we're going to go ahead and take a look, and it is at 9 inches. So we're going to go ahead and take our brake mic right here. This is kind of cool because it's kind of almost like your guys' dial indicator, where there's a little button right here that it pushes on it, and it causes the gauge to move. So we're going to go ahead and set our brake mic to 9 inches. So hopefully you'll be able to see it, but I'm going to go ahead and loosen this up and put it out. So as you can see right here, we have a 9 and an 8. This is going to be 9 and 8 inches. So since we know our brake drum is 9 inches in diameter, we're going to go ahead and move this down the teeth until we get to the 9. Go ahead and tighten that up. And we're going to do the same thing on this side. So this side, we actually have 9 and 10. However, again, we want to go ahead and take it to the 9. So we're going to go ahead and move it on over till we get to the 9, tighten it back up. So we're going to go ahead and take our brake mic, and we're going to go ahead and pop it into our drum. So we want to make sure that it sits fully on these lips that we see right here. And we're going to go ahead and take the mic, and we're going to go ahead and rotate it around the drum in a couple different spots. The reason why we're doing this is because we want to try to find the place that is going to give us the biggest number reading on our gauge. And so it looks like here, alright, so it looks like we're getting the biggest number that we see here is going to be a 30. So that's going to be 30 thousandths of an inch. We're reading at 9.03 thousandths of an inch. And when it comes to brake drums, it's important to remember that when you guys are machining it, unlike rotors where it gets thicker or thinner when it machines, our brake drums are actually getting wider. So we want to make sure we're paying attention to that, and that's why we want to get the biggest number possible, because that tells us how thin that particular drum is in that area. So we're going to go ahead and take a look at our actual brake shoes. Fortunately for this particular set of shoes that we have, as you can see that there's these little tiny holes along the side. This means that this brake shoe is actually riveted. It's not bonded, which is just where the pad is glued onto the backing, like our brake pads up front. So when we can't actually use this because when we look at it from the side, that's not giving us an accurate reading. And so what we're going to do is we're going to go ahead and take our tire depth gauge and we're going to go ahead and measure it in multiple spots on the rivets. So it's important that we're doing this because we get to do the outside and the inside measurements, because sometimes what can end up happening is our hold down springs can be bad and it actually causes the brake shoe to kind of pivot a little bit, and one side will wear out more than the other. Alright, and now some of these rivets look like they have some dirt in there, so we're going to go ahead and just clean it out real quick so that way we can get an accurate measurement. And then again, we're going to go ahead and take our tire depth gauge and we're going to go in multiple different places. So this one looks like we got, this one's actually 2 30-seconds. And then we're going to go down here and we got 2 30-seconds. And then we got a little over 2 30-seconds. And so you can see it's important to make sure that we're doing measurements in multiple different places. And again, we're doing it through the rivets itself, because the rivets actually are riveted in to the brake lining, and there's just a little bit of brake lining that's still left that's in the rivet. So when the brake shoes actually wear down, it's going to wear down to the rivets first before it wears down to the plate. So another thing that's important about to remember when you're doing brake drum inspections is there's a lot of different components on here that aren't in our front brake discs. So we have a bunch of springs, we have our wheel cylinders, we have our self-adjuster spring, our self-adjuster star. So we're going to go ahead and take a flashlight and we're going to go ahead and take a look around. We want to make sure everything looks good, there's no issues. So we're going to go ahead and take a little screwdriver right here, and we're going to go ahead and actually lift up the dust boost on the wheel cylinders, because we want to check to make sure if there's any fluid that leaks out. Because dust boosts are meant to keep out dust and not to keep in fluid. So if it is leaking, then we want to make sure we replace those wheel cylinders. And actually, in fact, this particular one, it is leaking some brake fluid from the wheel cylinder, so this is going to be something we're going to recommend to get replaced. Although it does look like our brake shoes are actually in good condition. So again, we're going to go ahead and take a look, see if we notice anything going on. So we're going to go ahead and take a look down here at our self-adjusting star, and it looks like our lever is actually no longer touching our star, which is not a good thing. So we're going to go ahead and take a look and see what's going on with that. So it looks like our self-adjusting cable is actually broken. So we're going to be recommending a hardware kit for that, so that way we can go ahead and replace that, so that way we make sure that the lever is touching the star like it's supposed to. So now that we've done the measurements on the brake rotors and drums and everything like that, we're going to go ahead and figure out whether or not those measurements are still within specs. So this is a book for 1973 to 2003 disc and drum brake specifications. We're going to find our 1995 Jeep Cherokee, which I've already done right here. So we have our Jeep, and from 94 to 2001 Cherokee. So we're going to find our nominal thickness for our brake rotors. So our nominal thickness goes down is at 0.950, and we measured 0.948 of an inch. So we know that is within specs. If it wasn't so close to the measurements, our minimum machining that is allowed is 0.894. So we actually have 50 thousandths of an inch of difference between where the machining is, minimum machining, so pretty much anything past that point, we would want to discard it. So we are actually perfectly within the specs. And then we're going to take a look at our drums. So we have 9-inch drums, as we remember, so 9-inch right there. That is the nominal thickness, so pretty much what it starts out with. And then maximum machining is 9.060, and we measured at 9.030 of an inch. And as our typical rule of thumb is, you have 30 thousandths of an inch of difference between your limit of maximum machining. So since we're at 9.030 and our maximum machining is at 9.060, we are just within specs to be able to go ahead and machine our drums. Alright, so as you guys can see, we're putting the vehicle back together. We went ahead and finished up our brake inspection, and it looks like the front brakes are all good, the lining's good, the rotor is within the manufacturer specs. As far as the rear brakes go, we are recommending the wheel cylinders as well as the brake hardware kits. We are also recommending, as preventive maintenance, the front shocks and the rear shocks because they were leaking. So the initial complaint that the vehicle came in for was actually spongy brakes as well as having kind of a loss of braking power. After talking with the customer as well as explaining what we found and everything like that, apparently it's a very notorious thing that the gentleman has had, where he's always had that issue with the braking power since he had the car. He decided that he's actually going to go ahead and, instead of replacing the wheel cylinders and getting the hardware kit and everything, he's actually just going to go ahead and do a conversion kit. So he's going to go ahead and go from the rear drums to rear disc brakes. And he's also going to be replacing the front and the rear shock absorbers. So we're going to go ahead and do that at a later date. We're just waiting on the parts to get in, and then we'll go ahead and knock out the conversion kit as well as the shock replacements. As you can see, we've already started putting the vehicle back together. So we're just going to go ahead and finish that up, and we're going to use our impact, and then we're going to be using a torque stick. The beautiful thing about a torque stick is it's going to give even, consistent foot poundage on all the lug nuts that we have, which is this one is at 80. And this is beautiful because we can just go ahead and knock it out, and we don't even have to worry about it. But before we start, it's always important that you make sure that you put the lug nuts on at least a couple threads. You do kind of want it to have a little bit of a play on here, so that way when you go ahead and use your torque stick and your impact, it can go ahead and torque properly. So I'm going to go ahead and... So I like to go ahead and kind of shake it when I'm torquing at least the first one. We don't want to put it all the way, just to make sure that the other ones can kind of help it get into the place that it needs to be. And you always want to go ahead and do it in a star pattern if it's 5 lug nuts. You never want to go around in a circle. You always want to go kind of across from each other. And now that I have them done, I'm going to go one more time and kind of blast it with it. Now again, the beautiful thing is with the torque stick, it's going to give even, consistent torquing all the way around, and it's not going to go crazy much because again, this is only torquing to about 80 foot-pounds. So now that we have all the tires on, we got them torqued down with the torque stick, we're actually going to go ahead and do one more thing. We're going to go ahead and torque it down with the torque wrench. So what we're going to do is we're going to take a look at the specs for that. So I have a 95 Cherokee torque. So it's going to be in the range of 85 to 115. So we're going to go with about 100. So we're going to go ahead and take our torque wrench. And what we're going to do is we're going to find the foot-pound there. So it's going to be 100. And we're going to go ahead, lift this sleeve up. We're going to go ahead and spin it until we get to the 100. Alrighty. So we're at 100. We got our socket on here, and we're going to go ahead and drop the vehicle, and we're going to go ahead and torque it down. Alright, so we're going to go ahead and take our torque wrench now that our vehicle's down on the floor. And we're going to go ahead and, again, we have it at the 100 foot-pounds already preset. And just like we did with the impact, we're going to go ahead and torque it down in a star pattern. And then we're going to torque it down until we hear that click. Okay. Now, a great tip that you can do is when you're doing torquing down the vehicles, since we still have the arms here, what we can do is we can grab the arm and pull it out. And this pretty much lets us know that we went ahead and torqued on that wheel, so in case if something happens and we have to walk away for a second, we already know this wheel is torqued, the other ones aren't, so we have to, so we don't have to redo this one, and we can just continue on.